In this video, we're going to look at polynomial function key features. So polynomials are named by their degree. So remember, the degree is the largest exponent of the polynomial. So if x squared, if 2 is the largest degree, largest exponent, it would be quadratic. X cubed, cubic. X to the fourth, quartic. X to the fifth, quintic. X to the sixth, sextic. X to the seventh, septic. X to the eighth is octic. X to the ninth is nonic. And x to the 10th is decic. So those are just the names of the first 10 polynomial functions. All right, another key feature is the end behavior of the polynomial. So the end behavior is just what it's going to look like as it continues going. The end behavior of a polynomial function is determined by looking at the behavior of the graph as x approaches positive and negative infinity. So we're just going to look at a couple of graphs. So this is a graph of x squared. So we can determine the end behavior, meaning if this graph continue going in both directions, as the x values continue going towards negative infinity, because remember, this just gets more and more negative, so it go towards negative infinity, the y values would increase. So the y values are going towards positive infinity. So as x goes towards negative infinity, y goes towards positive infinity. You can just write infinity, but you can also put the plus there. It just helps you differentiate between the negative and positive really easily. All right, you also have to look at it as the x values increase. So as x goes towards positive infinity, because remember, it's just going to keep going out this way, our y values are again going to increase, so go towards positive infinity. So y also goes towards positive infinity. All right, so let's look at a different one. We have x cubed over here. Here's the graph. All right, so we're going to look as first our x values go towards negative infinity. As x decreases, our graph is going to keep going down. So the y values are going to go towards the y values go towards negative infinity because the graph is going down. So y goes towards negative infinity. All right, now let's look as the x values increase, as x is going towards positive infinity. We can also see that the graph, as it gets going to keep going up, that means y is going towards positive infinity. So you can see they are different. Here as x goes towards negative infinity, y also goes towards negative infinity because it's going down. This one was different because both ends were going up. Okay? Hopefully the end behavior was pretty easy to determine. You're just looking at where your graph is going to continue going, in which directions. All right, next we have symmetry. A function can be symmetric about a line or a point. So if we look at our first function, we know this is a parabola. We know that it is symmetric. If I folded this over on itself along this line, it would be a mirror image. That's called the line of symmetry because it's symmetric if I fold it over on itself. So this would be a case where a line is our point of symmetry, or a line of symmetry actually. Okay, and the line goes through where x is 3. So this line would be called x equals 3. So that's the line of symmetry. Okay, then I also said that there can be a point of symmetry. If we look at this graph, we can see that they look very similar. If I took this point that's kind of right in the middle, and I just took this end and reversed it up, I could see that the graph would rotate on itself. So this is a point of symmetry. And so if you have a point of symmetry, all you're going to do is write down the coordinates. So this is where x is -2 and y is 0. You can see that even this spot, if I rotate it up, it would be this little turn here. And this turn right here, if I rotated it, it would be down here. So it is perfectly the same. That's why it's a point of symmetry, because it's not a line because you can't fold it on itself like this one. All right, so we're going to use those ideas, and we're going to identify the key features of this polynomial function. All right, so we're going to do one together, and then I'll let you do one on your own. First thing, we have x cubed plus 3x squared plus x minus 5. So very first, before we're going to identify any of this, we're going to graph it. That's going to help us to identify what's going on. All right, so I'm just going to use this function. I'm going to plug x values in, and we'll get y values out. Okay, and you can use your calculator to plug them in. All right, so I plug them in. I'm going to start with -4. And when you plug it into the polynomial function, you get out -25. I know that's way off my graph, but when I plug in -3, I get -8 out. So I did include a point that goes off my graph just so I can see what's the end behavior. When I plug -2, we get -3 out for y. -1 gives us -4 for y. When x is 0, y is -5. When x is 1, y is 0. And when x is 2, y is 17. Again, this is off the graph, but I can determine that in behavior. So now I'm going to graph it. Obviously, that first point won't fit on my graph, but when x is -3, y is -8. So knowing this point, I do know that my graph started down here. It didn't start up here, so that's where it helps me. When x is -2, y is -3. When x is -1, y is -4. When x is 0, y is -5. When x is 1, y is 0. And when x is 2, y is 17. So that's way off my graph, but it does help me determine what's happening. So I know that this one started down here. So that's going to go up and down, and then way up off my graph. This will continue going down. Okay, so now I can identify the key characteristics. Well, the degree, remember, that's just the largest exponent. So the degree is 3. So anything with a degree of 3 is cubic. So the name of this polynomial function is cubic. All right, the y-intercept, the point where it goes to the y-axis, is right here. So that's where x is 0, y is -5. In this case, we only have one x-intercept. Remember the point where it goes to the x-axis? So this is where x is 1, y is 0. All right, left, so the left side of our graph, the end behavior. So that means as x is going towards -infinity, we have to figure out what's happening to y. The y values go down, meaning they're also going towards -infinity. So y goes towards -infinity. That's just the sideways 8. All right, right in behavior, meaning the right side of our x values go towards positive infinity. We'll look at what's happening to y. As x increases, y is also going to increase. So y is also going towards positive infinity. Okay. All right, we have to see, is there a maxima, minima? Well, we know it's going to continue going up and down, so they're going to be relative maximums and minimums. So here's my point for my relative maxima, relative minima. So this one is where x is -2, y is -3. and relative maxima. I'm just abbreviating a little bit there. And our minima is where x is 0 and y is -5. And again, it's a relative minima. So it's not the true or absolute, because it continues decreasing and this continues increasing. Okay, symmetry. I know it's not a line of symmetry because it can't fold it on itself, but if I look at this point right here and I rotated one end of my graph around that, it would be a mirror image on this side. Or if I rotated this one up, it would go right over that point. So this is our point of symmetry. So it is a point, and that point is where x is -1, y is -4. All right, now we have to look at increasing and decreasing. So remember, when you're looking at your graph, you're looking at it from left to right. That's how you're going to read it. So going left, our graph is going up, and then it goes down and back up again. So I know my graph is increasing all the way up to the point where x is -2. So increasing intervals is where x is less than -2, and then it goes down, but it goes back up again after I get to where x is 0. So, and where x is greater than 0, it starts increasing again. All right, decreasing interval is between here. So that means that's where x is greater than -2, but it's also less than 0. Okay, you see how this is the point, the values between. It doesn't include, neither of them include where x is -2 and x is 0, but the decreasing is between those. All right, positive intervals. So this means where our y values are positive versus the y values negative down below. All right, so positive intervals. That's where our line goes to the x-axis right here, so we can look at the zeros or the x-intercepts. And we saw that our one x-intercept was where x is 1, meaning right here our y values are going to be positive anywhere where x is greater than 1. So positive intervals where x is greater than 1. You see, this is the point. We have y values that are positive, and that means everything else is below the x-axis. So that's where x is less than 1 would be everything below the x-axis. Okay, hopefully you understood that. I'm going to have you try to do one problem. We'll go through the answers after you've attempted it. So we have x to the second power plus 3x plus 2. All right. Hopefully you're able to work this one out. So I'm just going to create a table. So we're going to plug in x values, get out y. All right, I plugged in -5 to get out 12. -4, where x is -4 gives us 6 for y. Where x is -3 gives us 2. When x is -2, we get 0. When x is -1, we also get 0, but this is quadratic, and I know it's a mirror image, so it's going to be symmetric. So I know there's going to be a point in between this. So I'm going to pick where x is -1, y is also 0. When x is 0, y is 2. And when x is 2, when x is 1, change that into 1. Y is 6. When x is 2, y is 12. See how our values increase here and then decrease? They're the same, so there has to be a point that's going to be our vertex. So I know that point is going to be at negative 1.5. It's the x values are going to be symmetric also, so here it's increasing by 1 every time. So what's halfway in between to find the vertex? And if I plug in negative 1.5 into my function over here, I get out negative 0.25. Okay, and then I'm going to graph these. X is negative 5, y is 12 is off my graph. When x is negative 4, y is 6. When x is negative 3, y is 2. When x is negative 2, y is 0. When x is negative 1.5, y is negative 0.25. So about there. When x is negative 1, y is 0. When x is 0, y is 2. When x is 1, y is 6. When x is 2, y is 12. Okay, so this is what my graph looks like. All right, so the degree is 2. It is a quadratic. All right, y-intercept goes through the y-axis at 0, 2. X-intercept, there's 2 of them. We have negative 2, 0 and negative 1, 0. All right, now looking at in behavior. Looking at the left in behavior, when x goes towards negative infinity, y goes towards positive infinity because it's going up. So look at the right side. When x goes towards positive infinity, we have y increasing. So y is still going towards positive infinity. All right, maxima. Well, it just keeps increasing. It keeps going up. So we don't have a maxima. It's just going to keep going up forever, going to a positive infinity. So we have to look at the minima. It is an absolute minimum because this is our very lowest point. It never gets lower than that. And I found that that point was negative 1.5, comma, negative 0.25. Whoops, this one goes down here. It is the minima. Okay, so symmetry. We have a line of symmetry going through that vertex. Because if we folded it over, it'd be a mirror image. So this line of symmetry is where x equals negative 1.5. All right, so now we're going to look at increasing and decreasing. So when we look at our graph, we always look at it going from left to right. So it goes down, then up. All right. So increasing is from our vertex continuing to go up. So where our x values are greater than, we know our vertex, the x value of the vertex is negative 1.5, and decreasing is everything below that. So all the x values that are going to be less than negative 1.5. Okay, so that vertex always tells you where the change is. And remember, it does not include the vertex. So it's not or equal to. All right, positive and negative intervals. So this one's a little tricky because the only negative intervals, it's just below the x-axis. So there's just that little vertex down there. So we have to use the x-intercepts or the zeros to help us determine the positive and negative intervals. So here's our x-intercepts. So that means It's positive from everything less than where x is -2. So all values where x is less than -2 is going to be positive. It's above the x-axis. And it's positive again after our other x-intercept where x is -1. So where x is greater than all these larger values, -1, it will be positive. It will be above the x-axis. All right, negative intervals. Well, it's between this. So remember, it's just that vertex area down there. So it's where x is. We're going to use these same points. But now it's going to be where x is greater than -2, but less than -1. So it's just a tiny little area between those two values. All right? Hopefully you are able to identify the key features of polynomial functions.